We're going to start with the fuel cap. The fuel cap is hooked to your gas tank. You guys fill up gas at the gas station. This cap seals the fuel inside of the tank. It has a little rubber gasket on the fuel housing that touches the housing to the cap, and we have locking tabs. Maybe you go and you twist this, it will click. It says 3 clicks, that seals the system. So the fuel cap is used to keep fuel from escaping from the tank. We're going to move through some stuff that has kind of evolved over the years. We're going to start out with this, the mechanical fuel pump. The mechanical fuel pump had a little rod that pushed on this little lever, and that rod was attached to the camshaft. And so it would push this, and there's a diaphragm inside of this pump, and it pulls fuel from the fuel tank, and then it goes out up to a carburetor. And so this would just be a little pump, kind of like a siphon pump type piece. It was all mechanically driven, and it would just pump like this and deliver fuel to a fuel bowl inside of this carburetor. So right here, this piece that is threaded in the carburetor, fuel would go in here, and inside of this carburetor is a fuel bowl, and that bowl has a little lever that moves up and down, and once the fuel sits here, it goes into these jets, and as the throttle opens, it draws more fuel into the carburetor from the bowl, and it mixes with that air to go through these throttle plates into the intake manifold. So this is all mechanically controlled. We use carburetors for years, from the early days all the way up until the 1980s was very common. As carburetors needed to be rebuilt and adjusted, General Motors come out with these little gauges here to help you rebuild a carburetor. This kit also has a throttle body injection kit that's used for adjusting purposes. So they had the throttle body injection and carburetor adjustment kit for enrichment purposes and to help with the fuel to allow the proper amount of air-fuel ratio to be entering inside of the engine. So manufacturers made kits for the carburetor to be mechanically adjusted and throttle body injection systems to be properly adjusted. This is a throttle body fuel injected system. Has 2 fuel injectors mounted directly above the throttle plates. You can see this on the 350 engine of General Motors vehicles in the 80s. This throttle body injection system will just spray fuel directly on top of the throttle plate and increase fuel or decrease fuel as needed. This is an inline fuel pump that will pump fuel up to the carburetor. They made these anywhere from 2 to 9 psi. We also use these inline fuel pumps for throttle body and port fuel injection systems that could reach up to 100 psi in pressure also. With the movement of electric fuel pumps, you can see that we have 2 wires here. There is power and a ground wire that energizes this fuel pump. This strainer or sock, some people call it a sock, a strainer, in tank fuel filter will take any sediments from the tank and filter it before it goes through the pump, and then it pushes it out through the pump. You can change these filters. They sell these filters whenever you buy a pump, if you need to change the pump inside of this housing. So there's these little pump or strainers that bolt into place, and it saves the fuel pump. So if you buy a fuel pump, you want to get a strainer with the new fuel pump when you change those. A lot of manufacturers will sell this as an assembly. So this is a strainer that's attached to our pump inside of this housing. So this pump, just like we have the pump before, is inside of this housing. And this housing has just more things than the pump itself. It has a fuel sending unit. So this fuel sending unit moves up and down according to how much fuel is in the tank. When the tank is empty, it's down here. When it's completely full, it's up at the top. So this alerts the driver on the fuel gauge how full the fuel tank is. We have a few lines here. So one is going through the fuel lines up to the fuel injectors. We have a return line, have a pressure sensor directly on top of the fuel tank to monitor the fuel pressure of the expansion of gases. And then we have our electrical piece here that delivers power to our fuel pump and our sending unit. So these little terminals will go to our fuel pump and our sending unit, and then it goes back through the wire harness to alert us what's happening. This is submerged inside of the fuel tank. So you can see these have springs. So we're gonna push this and it seals it into the tank so that we get the very bottom of the fuel tank and we can run the gas almost to empty before the fuel pump starts for any fuel. Some manufacturers will have a fuel pump separate, and you can see the lines here. This is attached to the fuel tank with our wire harness and the fuel sending unit here. Once the fuel is transferred out of the fuel pump, it's going to, on some manufacturers, go to an external filter. So these have fuel lines going in and out. This particular filter has fuel going in, fuel going out. There is words on it or arrows representing the flow of fuel. So this one goes in, goes out, in, out, and you can see this one here, it says flow with the flow going out. Fuel is transferred with still fuel lines on most manufacturers, so there will be hard fuel still lines that run from the tank to the fuel injector rail. We've got some plastic fuel lines here. These are attached to pumps. You'll also see these hard plastic lines that have fuel symbols attached to them going to fuel rails, and wherever we need to angle the fuel around something, we'll usually use these hard plastic fuel lines. When these break or they crack, they sell a fuel injection hose at the parts store. I want you to pay attention that this is not for fuel injection systems. So these are rated at certain PSIs. So this is a quick fix. It's not a permanent fix on most fuel systems. If you have lower fuel pressure, like a carbureted fuel system, these are perfectly fine. But on something that has more fuel pressure with fuel injected systems, we want to stay with the hard plastic or the steel fuel lines, because these are rated at higher PSIs. The type of system we have a little fitting here that usually is attached to the fuel rail, and it kind of looks like a bicycle tire Schrader valve on a tire, for example. This is threaded into place, and we can check the fuel system pressure on a lot of fuel systems, and it will give us a rated PSI. And we see what rated PSI that is, and we compare it to manufacturer specifications to determine if the fuel pressure is good. The fuel pressure isn't good, maybe we have a weak fuel pump, maybe the fuel pump needs to be replaced. So this is a testing gauge that we would check to see if there's proper fuel pressure to the fuel line. Some cars now will have electronic fuel pressure sensors, especially on direct injection systems that is rated at a higher PSI. This tester was used for return fuel systems. We had a fuel line in, fuel line out. It monitored the pressure and it was gallons per minute. So gallons per minute, maybe this little ball was getting good flow, low flow. We would see based upon that ball what would happen. So once we've checked the pressure to the system, some scan tools will tell us fuel pressure based upon the powertrain control module or electronic control unit that monitors those pressures off of a fuel rail pressure sensor. On most of our newer cars, we may need to go back to the gauges if it doesn't have those. Moving on to some fuel injection components, we've got 3 different styles here. The throttle body we covered earlier. This one was used by General Motors. They have little poppet valves. They kind of nicknamed this a spider because it looks like a spider. You can change these individual poppet valves out. Fuel goes in through here. And it's similar, it just has fuel inside of these little galleries. Fuel comes out back to the pump. So it's circulating fuel, and then these little terminals will open these poppet valves to allow fuel to be injected into the cylinder. This is sprayed directly into the intake manifold, not the cylinder, and it mixes with the air. One of the problems they had with these was this fuel pressure regulator. So you could change this fuel pressure regulator that holds pressure in the fuel. If it failed, it would just dump fuel into the intake manifold. While we're talking about pressure regulators, this is a pressure regulator. You can see that it's contaminated, it has rust, and this plugs into the fuel rail like this. And this has a vacuum hose attached. When the diaphragm fails, you would see fuel leaking out of this regulator. And fuel, when we unplugged the vacuum hose, if fuel squirted out, that was causing us our performance problem because fuel was being circulated back into the intake, creating it to be a rich mixture. This particular style was put into the fuel rail, and then this was taken back to the pump, and then this was regulated through the vacuum. And it has a diaphragm, and this style tend to fail because if fuel came out of here, we replaced this, and this was bolted directly to the fuel rail. So we had these regulators on the fuel rails, and these fuel rails have injectors attached to them. If these injectors failed because they were constantly spraying, or if they were closed, we could test these with an injector tester. So we have an injector tester here, and we could hook up a pressure gauge, and when we push this, it would click the solenoid, and it would send fuel into the cylinder, and we could hear it with that little clicking noise. Maybe you can hear that clicking noise. So we could test individual injectors to see if they were electronically spraying fuel, and on the connector we could even test if the light was lighting up with a Noid light. They have Noid lights to check for electrical signal. This checks for fuel. If I need to change the injector, I pull the little retaining clips off. These little retaining clips hold the fuel injector into place. They're just little brackets like this. And I just grab the fuel injector and I pull it up and out of the injector rail. Might have to twist it a little bit to remove it. And these O-rings, if they get ripped or broken in any way, can cause a fuel leak. So there's one that goes the fuel rail, there's one that goes the intake manifold. When we install these, we want to put a light coat of engine oil on the O-ring. So clean, fresh engine oil, a light coat, and then we just push them into place. And then we're going to use this little retaining clip to make sure that it holds the injector back onto the fuel rail. If we don't have that clip put in place, then of course the injector will not, it will pop out if we forget that clip. While we're on the subject of fuel injectors, these are in a variety of shapes and sizes here. These are all port fuel injectors. Port fuel injectors can fail over time. The solenoids will go out in them. Sometimes they become contaminated, so we might have to clean the fuel injectors. They sell this fuel injection cleaning machine that will clean the fuel injectors, and we add a additive into this tank with gasoline, and we hook it up to the battery and it pressurizes the fuel system. This is directly hooked to the fuel rail. We don't want any of the gas going back to the fuel pump because it will ruin the fuel pump. And once we pressurize this fuel system, we run the car off of this motor vac carbon cleaning system. It cleans the fuel injectors, and it also cleans the valves and the pistons inside of the cylinder. So it's great for cleaning carbon off of intake valves and also the piston heads. So this is one of the machines that's used to clean the fuel rail and the engine itself. They sell some fuel injection cleaners that you can add to the tank. Those aren't as effective as the motor vac, or the OTC has a fuel carbon cleaning system that works great too. Okay, so these are port fuel injectors. There's the O-ring that goes to the fuel rail, and then there's a O-ring that goes to the intake manifold, and then here's our electrical connector that powers the solenoid inside of this fuel injector. So fuel goes in from the top, and then electrically it opens the solenoid and it's going to spray the fuel inside of the intake manifold. So these port fuel injectors here are fuel injectors that's rated in most cases up to about 60 pounds per square inch. Some fuel injection systems go down to 25, some will move up to 35, 60, depending upon the fuel pump, what's the pressure of the fuel from the fuel pump, and then what is needed for the engine. Moving over to this style of injector. This is our direct injection type fuel injectors. You can see the difference. We have a rubber O-ring. This is a little Teflon type piece here. This is actually pressed into the cylinder head. And so these have a retaining clip and bolt that holds the injector into the cylinder. So this sprays directly into the cylinder. This sprays on through the intake valve. So this has a lot of pressure that is going to be push up on this injector, because as the piston moves up and down inside of the cylinder, the fuel injector is spraying directly into the cylinder instead of behind the valve. So these are direct injectors. These direct injectors have fuel that goes in the same way from the fuel rail, and then it goes through here. There's a solenoid that controls this, and it sprays the fuel inside of the cylinder. So again, these are held in place with a bracket and a bolt to hold it inside of the cylinder. So we have an injector pump on the fuel rail, and that up to 500 psi is going through into the cylinder to expand with that piston and the pressure inside of the cylinder. Because it has to withstand that pressure, it has to spray that fuel in there. So that's why these have to undergo high pressure ratings.